In signed versus unsigned binary, there's a few things we need to know. So if we're trying to represent the number 2, well, in unsigned binary, we just use what we are used to, which is putting the place values in, 16, 32, 64, 128. And we just assign the correct bits in the correct columns to denote the number 2. The problem with unsigned binary is that we can't represent negative numbers. So for instance, we can't represent -2. The solution to this, or 3 solutions to this, are sign and magnitude, 1's complement and 2's complement. Now we will end up using 2's complement as our main method of representing negative numbers, but at this point we just need to know that these exist. So for sign and magnitude, the same applies in terms of the first 7 bits of this byte in terms of place values. So 1, 2, 4, 8, 16, 32, 64, but we lose the 128's column. We lose it to reassign it to be our sign bit. So essentially, if we have a 0 in sign and magnitude, that denotes that this is a positive number, in this case, positive 2. We will show how we negate or make negative this value 2, so -2. In 1's complement, it's exactly the same as being unsigned. So we still have 1, 2, 4, 8, 16, 32, 64, 128. So it appears as a positive number that this is just the same as unsigned. We'll see what happens when we negate this to turn it into -2. Now 2's complement is slightly different still. So we have 1, 2, 4, 8, 16, 32, 64. But whatever the most significant bit is, the bit at this end of the number, we turn it negative. So we still put its value in, but we turn that value negative. So let's make negative this value to -2. To do that, in sign and magnitude, well, all you do is you set this first bit to say that this is now a negative number, and you just write down the value for 2. Okay, so all that's happened is we flipped this bit to denote that this is now -2. In 1's complement, complement means to just flip the bit in a bitwise fashion. So if we flip that bit to 1, that becomes a 0. We flip all of these to 1. In 1's complement, this is telling us that this is -2. It's just the exact opposite bitwise fashion of this. In 2's complement, well, we kind of have to do some arithmetic here. We have to start with flipping this sign bit to a 1, but what that entails is turning this entire number now into -128. Then we need to add on 64, that brings us to -64. Add on 32, -32. Add on 16, we're now at -16. Add 8, we're at -8. Add 4, we're at -4. And add 2, we get to -2. So this is the 2's complement for -2. Much later we'll talk about the notion of, instead of just flipping all the bits, we flip the bits and add 1 to give us the negative version of a positive number. Again, at this point, we just need to know that signing does exist and that there are different methods to achieve it.